Sorry about it. Okay, so let's do the second question. Can somebody give me the mean? Mean is 0.48, is it? Was it 0.48?
Yes.
0.48. And standard deviation is?
0.0505.
Okay, so they want to know which score is closest to the value of 2 standard deviations below the mean. Now, okay, now this is not standard deviation. This is actually variance. So then, how do we get the standard deviation? Isn't this square root of 0.0505? How much is that? Is that correct? For 3 decimal places, can we agree 0.225? The square root of 0.0505? So standard deviation is that into 2 standard deviations is how much? Point. Is that correct for 2 standard deviations? Right. Now we want to find out the closest score, which is 2 standard deviation below the mean. So 0.48 minus, this is 2 standard deviations, we end up with 0.03, correct? So then what is the closest score to 2 standard deviations below the mean? What do you have there? You actually have 0.03 as one of the scores, isn't it? The very first score is actually 0.03. So your answer to that question would be 0.03. 0.03 is 2 standard deviations below the mean. Okay? Is that clear to everybody? Okay, so, if it's not clear, I'm hoping.
Yes.
Yes, okay. Right.
So
not, yeah,
but I missed out on that, I guess, the variance, like converting the variance to the standard deviation.
Right,
to do that sum.
right.
I just took the variance, yes.
As the standard deviation. So yeah, there is that thing there, no? The little tricky thing. Variance of the scores is given as 0.0505. That is not the standard deviation. So to get the standard deviation, you need to actually get the square root of the variance, right? Now we have a different kind of question. Let's see what they say. A neuropsychologist is studying a patient with brain injury. The patient was given a series of tests. In each test, a higher score represents better performance. For each test, the patient's score was compared against the scores for a large control group of participants. Using the mean and standard deviation from the control group, the neuropsychologist obtained a standard score for each test. The standard score in this case now would be the Z score, right? Each test is listed below together with the standard score, which is the Z score that the participant obtained. Select all of the tests for which the patient's score was within 1 standard deviation of the mean of the control group. Right. Where are you within? Now you have the Z score. Now, Z score means what? How many standard deviations are you from the mean? That's what the Z score means, right? How many standard deviations are you from the mean? So you have a plus 1.93. What does it mean actually? It means that particular score is 1.93 standard deviations above the mean because it's a plus, right? So is it within one standard deviation then? Can we say it's within?
Yes.
No,
No?
because it's 1.93. So the Z score, if it says 1.93, that means it's 1.93 standard deviations above the mean, right? So that's your Z score. That's what it means. So the question is, what are the scores within one standard deviation? Within one standard deviation. That is what we are looking at. So if it's 1.93, you're going beyond one standard deviation. 0.93 is gone beyond one standard deviation. Okay?
But
So,
Varuni,
yes.
if like you are not given scores, then I'm sorry, I didn't
Okay.
get that.
So you only have the Z score here. You only have the Z score. We don't know the mean. We don't know the standard deviation. All right. So all these, now there are different tasks. The standardized score, the Z score is given. Standardized score means Z score. So you have different tasks where you are given the Z score. The question is, select all the tasks, right, where the score is within one standard deviation, right? So here, when it stays within one standard deviation, we know this Z score. What does it mean, Z score? Is, let's share that, let me share the question paper with you. Right. Okay. So here, the utensil star standard score is 1.93. So 1.93 means what? That the whatever the score is not within one standard deviation. 1.93 means it's 1.93 standard deviations away from the mean. It's not within. But we have to find the scores which are within one standard deviation, right? So that is not one of them. B is minus 2.47. Again, it is far away from within one standard. If it's less than -1, yes, but this is minus 2.47, so that's also not there. The London Face Recall Test, that is also minus, sorry about that. That is also minus 1.67, is more than one standard deviation below the mean, right? Minus means below the mean. Then the next one, 0.03. Now, is that one standard deviation within the mean? One standard deviation. So between -1 and +1 standard deviation. It is, no? So you can tick that one, right? Because it's within one standard deviation. Then the next one, can you tick that one? 1.15? No.
No.
Yeah. Next one, minus 0.65. Is it within?
Yes.
Yes. Next one, plus 0.89.
Yes.
Yes. Next one, minus 1.83.
No.
No. So we have three scores here. D, F, and G. Okay. So I hope patient score was within one standard. Within means between -1 and +1, because you're having the standardized score 1.93 means your score has been 1.93 standard deviations away from the mean. That is why it's not within, it's beyond. All right. So now, same narrative here, question 3, same narrative should be working for this question 4 also. Select all of the tests which the patient score was more than one standard deviation below the mean of the control group. More than one standard deviation below the mean. Now, do we know to take out all the pluses? None of the pluses are going to come here because we are looking for below the mean, right? So no pluses in this, that's for sure. So more than one standard means it has to be, it can't be 0.0 something, it has to be 1 point something and up, right? So it has to be all minus figures. More than one standard deviation below the mean. So lip reading task minus 1.64, yes or no?
Yes.
Yes. Once more than one standard deviation below the mean. Minus 2.48?
No.
Isn't it more than one standard deviation below the mean? It's -2. So
Okay.
it's actually,
So
yeah.
we are not looking for the within.
No, it's below.
Yeah.
It's below the mean. More than, it's more than one standard, right? More than one standard deviation below the mean. So minus 2.48. So these words are, see, that's why the words are important, isn't it? Plus 1.98, we know that it's above the mean, right? Above 1.98 standard deviations above the mean. So that doesn't come here. It's not part of our answer. Face recognition, minus 1.82. Yes or no? Yes. Okay. This task, minus 0.62. Is it more than one standard deviation below the mean?
No.
No, because it's only 0.62, right? Oh, sorry. So that you don't take. Plus 0.81, obviously not because it's more. This one plus 1.18, obviously not. It's above the mean. Again, plus 0.04 is going to be above the mean. So those don't figure. So our answers would be A, B, and D. All agreed? Your Z score tells you how many standard deviations far away from you are, from the mean that your score is. So even if you have the Z score, you can quickly say you are so many standard deviations from the mean. So anybody know A-level results Z score? What are the normal Z scores for what we get for A-levels? Anybody know this? Have an idea what is the Z score? I actually don't know. What are the normal Z scores? So I can only, tell you, let's say it's 20, let's say. What does 20 mean? It's a horrible Z score then. 20 standard deviations above the mean. That is extremely bright. Usually you don't have 20s like that. It's Z scores should be ideally less than 2, So if it's, let's say your Z score is 1.7, your 1.7 standard deviations above the mean. That's what your Z score means. If one of the A-level students get a Z score of 1.9 plus 1.9, you're 1.9 standard deviations above the mean, which means you're quite clever And if you're below the mean, let's say 0.5 standard deviations below the mean means you're within the average 68% in any population. It's that within one standard deviation is where you get 68% of the scores. This is a standard because you can only do this calculation on a normal curve, right? That's very important to understand. It is there in your note. These z-scores, right? Z-scores are relevant when we know that your curve, your bell curve, is a normal distribution. A normal distribution means you have symmetry, half on this side, half on this side. There is no skew, right? This is called a normal distribution, right? It's very important. We can only work out z-scores when the set of scores are arranged in a normal distribution. If, let's say, IQ is not normal and there is a positive skew, then we cannot do this for IQ scores. But we have found out, our psychologists have found out, IQ scores lay on a normal distribution. So the mean of IQ is at 100 and the SB, standard deviation, is 15 for IQ. So you have one standard deviation below the mean is 85 and one standard deviation above the mean is 115. And within one standard deviation, what is the percentage that you get in a normal curve, normal distribution? You get something like 68%. So when you take IQ, for example, 68% of the whole population of this earth will fall into an IQ of between 85 and 115, right? So that is your within one standard deviation. That is why in papers, in research and everything, it's important for us to understand what does this mean, this within one standard deviation. Now, let's say your IQ is within the second standard deviation. That means what? 115 to 130. This space is 2 standard deviations, right? The second standard deviation. This is the first one standard deviation. This is more than one standard deviation. Your textbook might give you the percentage. I can't tell you off the top of my head exactly what percentage of the population is in this section, right? But there is a good percentage that is already calculated for any kind of score. That's how it is. If your scores fall on a normal distribution, right? Symmetrical normal distribution. So there you say you are actually quite clever. And when you go higher than the second standard deviation, you have the gifted, right? And on this side, you have the retarded, right? That's the retarded. So less than 70. So 2 standard deviations. So this is if your IQ is less than 70, you say you have some kind of mental retardation. Do you see how this is applied in psychology and real life situations? That's how standard deviations are applied. And when we measure IQ and for different jobs or schools, colleges, all kinds of IQ tests are given. SATs, you can also say, it's a form of an IQ test. It's a form of an IQ test. You're measuring your verbal and mathematical skills. You're trying to figure out how intelligent you are. right? So, okay, I hope that is clear. We'll go back to our questions PDF. Right, then we have question number 5. The following 5 scores were obtained in a psychology experiment: 1, 3, 2, 8, and 9. Find the sample standard deviation for these scores. Give your answer to 2 decimal places. Answer should be accurate to 2 decimal places. So standard deviation 1, 3, 2, 8, 9. 1, 3, 2, 8, 9. Let's work that out quickly. Right. So our scores are 1, 3, 2, 8, 9. Correct, no? So in our chart, oh my gosh, I'm going all wonky. 1, 3, 2, 8, 9. Okay, so what is the mean? Can somebody give me the mean? What is the mean of these? One, 3, 2, 8, 9. What's the mean? 9 plus 1 is 10, 10, 18, 19, 20, 23 divided by, yeah, 23 divided by 5, right? So 23 divided by 5 is 4.6, correct? Okay.
Yes.
So now we are going to first of all see the distance for each score from the mean, because now we have to calculate the standard deviation. So first of all, we have to get the variance. So 1 minus 4.6 would be minus 3.6, agreed? 3 minus 4.6 is minus 1.6. 2 minus 4.6 is minus 2.6. I hope this is correct. 8 minus 4.6 is 3.4. Right. Tell me if I'm wrong. 9 minus 4.6 is 4.4. This should all add up to 0 because we are going up above and below the mean. So they should all cancel out. That's how we know whether our calculation is correct. So let's see whether that is correct. We will know by trying to get this. Yeah, it's correct. Right? So I hope all of you figured this one out. Our next step is calculating this x minus x bar square. Now we are going to square this. So can somebody tell me the square of minus 3.6 into minus 3.6? What's the calculation? 10 point something? Nobody? $12.96. Next one. $2.56. Next one. .76. Next one. 11.56. Last one. 19.36. Now, if you add these up, what do you get? 1, 2, 3, 4, 5. Is this what you get? 53.10. Is that correct? $53.2. Sorry. So looks like that's the amount. So now to find the variance, what do we do? So variance is 53.2 divided by n minus 1, which means 53.2 divided by n is 1, 2, 3, 4, 5. 5 minus 1 equals 53.2 divided by 4. What do you get?
13.3.
Right. You get 13.3. Are we all agreed that is your variance? All right. So you have yeah, 13.3. So, and then you have your standard deviation, or SD, would be 13.3. Square root of that is what? Is it 3.64? Did everybody get 3.64?
Yes.
Right. Everyone else is very quiet. I'm just hoping that that you have arrived at 3.64, which is the correct answer. And we have to give it to 2 decimal places. It should be accurate to 2 decimal places, right? So do we need to go through that again, or did you remember what we did from last class and you kind of had a little bit of revision? I hope it was okay. Yeah? Right? Okay. So, all right. Then we will go to question number 6. A neuropsychologist used a standard test to assess a study participant's memory, and the participant obtained a score of 61. Scores on this test have a mean of 85, median. Okay, let's write down these numbers in our whiteboard. So let's get rid of all these. Now, What is the score? 61, no? Score is 61 because I can't see the question paper when I'm on the line.
Yes.
Right.
61 score.
And the mean?
85.
85. Median?
88.
Yeah. What else do we have?
The range. 1 minute. The range is 58, 106.
58, 106, is it?
Yes. Yes.
Okay. So they are giving both the minimum and the maximum. All
And
right.
the deviation is 12.1.
So what is
deviation.
Right? What is the question they're asking?
Calculate the study participant's standardized score for the test. Give your answer in 2 decimal places.
So what they're asking is, what is the Z score? Right? They're asking for the standardized score. So what is our Z score? X minus X bar divided by SD, right? We are going to see this score of 61. How many standard deviations is it above or below the mean? That's basically what they're asking for. So we have X at 61 minus mean is 85 divided by 12.1. What do you get? Can everybody agree on this one?
Yes.
Okay. Right. So it's a minus 1.98. So I hope you managed to get that. Let's go to question 7. I'm very worried. No sound from Bhumika or Vino, Jito. I hope this is like.
I'm in full agreement with you, Varuni.
Yes. Me too.
Okay. Right. All right. These are actually the simplest calculations. So I do hope it's not totally flying over the head like, oh my gosh. Okay. You're kind of getting it. I have some good feedback from Jessica because she has done statistics before, and she told me that she was so confused that she changed her degree or whatever just to avoid doing statistics. And she told me that she's finally starting to understand, these standard deviations and the variances and all that. So she has done it before, so I know it will be easier for her to kind of get it. But most of you have not done it before, so I'm just I hope it's not going too fast and you're kind of getting an idea, right? You're kind of getting an idea what this is all about. Right, so let's go to question 7. Scores on the ATI, Abbott test inventory. So we have lots of these inventories and the questionnaires and the scales, right? Are distributed with a mean of 255 and standard deviation of 56. Alex has completed the ATI and his score was reported as a Z-score of minus 1.75. What was Alex's original score on ATI? So here, okay, now someone will have to give me these numbers again because I now I can't see the numbers. So
mean is 255.
Mean is 255. Okay.
SP is 76.
Right.
his C-score is minus 1.75.
Okay. So, okay, go ahead.
Right. Minus, that's all we have. And we
Yeah.
have to find Alex's original score. So the
Okay.
same formula, Z score is equal to X minus X bar, that's the mean, divided by SD. So now we have this one, we have this one, we have this one. What we don't have is this one, correct? So we take this X, that's what we are trying to find. We take X into one side of the equation and put everything else into the other side of the equation. So this is a little bit of mathematics we are going to do. I hope you remember this from your school days. If you keep X on this side of the equation and take all these into the other side, what do you get? You have your Z score. SD, you are dividing by SD, which means when it comes to this side of the equation, SD would be multiplication. If this is under, when it moves to the other side of the equation, it becomes a multiplication. Division becomes multiplication, right? And then that's the first thing that you do. The second thing is you are taking this minus X bar to the other side of the equation. So it becomes plus X bar, right? So when we take this as a whole to this side, it becomes plus. It's a minus figure. Now on this side, it becomes a plus figure, right? So I hope this is clear. Is it into, sorry. Sorry about that. Is it multiplied by SD plus the mean should give us our original score. Now Z is minus 1.75 into 76 plus 255. What is that? So, do you agree this is minus 133 plus 255? What would that give you? It's the same as writing 255 minus 133, correct? What is that? $122, right? You get 122. Did everyone get 122?
Yes.
Right. So the average, the mean is 255. Alex's score is a minus figure, which means obviously we already know he is way below the mean, right? 1 point, almost 2 standard deviations below the mean. That's what it means. 1.75 Z score, almost 2 standard deviations, right? So if you think of his score in the normal distribution, right? The mean here is 255. That's what most of the people have scored. And we are already told that his Z score is 1.75. So this is your 1. This is your 2. What are these? The standard deviations, not the scores, right? 255, I'm talking about the standard deviations. So this is 1 standard deviation, this is 2. Now Alex is somewhere here at 1.75 minus, right? Minus. And we know that he didn't make it even in the average, right? He's beyond this 1 standard deviation. He's actually in the not so bright section of the population. Below, no? It's a minus score, which means it's below. Can you see now how that has worked out? Right. I hope that was clear. 122 was his original score. Right. Now, the last question is scores on the Bellingham test of cognitive function are normally distributed. It has to be normally distributed for us to be playing around with these Z scores, right? Always normally distributed means that it's a symmetrical curve, no skewness, right? Scores on this test of cognitive function are normally distributed with a mean of 257 and a standard deviation of 40. Bella has a BT score of 323. Convert Bella's score to Z score. 257 SB is 40. So that's correct information. No, I have 323, 257, and 40. So Bella's Z score would be 1.65. Can someone give me with the correct sign what is the answer for Bella's Z score?
$1.6.
Yes, 2 decimal places, 1.65. I hope everyone got that. So what does it mean actually? In a normal distribution of this cognitive function, this particular cognitive function test, the mean is 257. Standard deviation is 40. Bella has scored, so your score here after one standard deviation is what? 257 plus 40 is 297, right? This is your first standard deviation. Second standard deviation is 297 plus 40 would be 337. Yeah, 337, I think, right? So Bella's score is at 323. So the second standard deviation is here. Her score is somewhere here, 323, right? So we know already she is way above average, right? Way above average. So she is in the second bit here, and 323 is her score. So she's 1.65. Her Z score is 1.65. So in cognitive function, she's placed quite a bit above average. All right. So this section here would be extremely above average, extremely high score, right? This would be above average. This whole thing is average. That's how it goes. Always normally distributed curves only, we can do this. We do this only with normally distributed curves. right? So now we are going to, okay, sorry, we are going to take a look at SPSS and try to get some, let's make up a file quickly to find out standard deviations, right? So let me get that going. Right. Okay. Now I think somebody will have to tell me about the book. Yeah. There is a, we are going to see how we can get the same information on SPSS, right? So let's take a look at this. Let's input some data. This is on your textbook, page 88. How to get standard deviation and Z-scores using SPSS, right? So let's first, in page 89, you have the data, age. We are going to look at age of participants. And first of all, what you do is in your SPSS, I hope you can see SPSS clearly. You go to variable view and define your variables, right? What is your variable? It is age, correct? Everybody agreed your variable is age, right? And then you have to be able to measure it. So in measurement, we have scale. We choose the scale measurement. So age is not nominal in this case because we are going to calculate mean and all these as standard deviation. So it has to be a scale measurement. Age, there are no decimal points, so we make it 0. And that's it. And we go to data view and we already have now our heading called age. So here we put in our data. What is our data? Let's okay, I can see here our data starts with 20, 25. These are the ages of participants. It's in your textbook, the same example we are taking. 35, 19, 17, 15, 30, and 27. So there are 9 participants in this particular study. These are their ages, right? And then your book tells us to do certain things, and we'll go and see what it is that we have to do, right? The second step is we go to descriptive statistics. We are going to analyze this data to get the SDs and the Z scores, right? Analyze, descriptive statistics, and descriptives. That's where we go. We choose the variable, put it into the variable box. So this is highlighted. I use this arrow to put it there, right? And then I go to options. I want to check the mean. I want the standard deviation, minimum, maximum. Okay, fine. Maybe I also want to see the range, right? And I'll say continue. And I'm going to, okay, press OK. Let's see what we get. Now, do you see this new screen or not? You don't see the new screen, no? I have to stop the share and show you that screen. Now, do you see it? I hope this is, do you see the statistics, descriptive statistics that we have got? N is, okay, 9 people. We have the range is 20. Now, how did we get the range 20? In your textbook, we know the ages run from 17 to the minimum age is 15, maximum age is 35. So your range is 20, that's correct. Minimum 15, maximum 35. It's calculated the mean for us at 23, and the standard deviation is calculated at 6.652, right? So we are getting the same, hopefully the same results as your textbook, right? So the textbook gives screenshots for each step that you need to do. Right, now we go back to the same analysis, descriptive statistics and descriptives. We tick this box, save standardized values as variables. I hope you can see this dialog box. Save standardized values as variables, standardized values. Now here we are talking about the Z-score. And we say, okay, you get the same thing. Now let's go back to our data view and see whether it has calculated for us the Z values. So I don't know if you're going to see the transition of the windows. Do you see now the Z age column? Do you see it or not? The screen has changed.
No.
No, okay. So now this is what happened to our data when we tick that small box, right, where it says to show standardized values. Automatically we are given the Z scores for each age, the Z score. Minus 0.4509, 1.80. So what does this mean? Now, when you have an Z score for the age, we know, what do we know? This is, let's say, this 1.80, this age of 35, right? This particular age of 35 is 1.80 standard deviations above the mean. Mean age is 23, like our the weight calculated and gave us at 23, and SD was some other number. So Z score is calculated and giving us each Z score, right? So that's how we work this out on SPSS, right? The age distribution. Now we can also check a histogram for age and see a normal, display the normal curve. Let's see what it gives us. Do you see this one? Do you see this, the curve, or not?
No.
No. Okay. So when we did the histogram, when we took out graphs and we asked for a histogram with the normal curve for this age, this is what we got. 15 to 35. Your mean age is somewhere here, 23, which it already calculated for us, mean at 23, right? And what can you tell me about this curve? What is this curve? Positively skewed, negatively skewed, or symmetrical? Nobody? No one knows?
Sorry, Varuni, my connection's all over the place. I keep missing some things. What did you ask?
The curve, do you see this as a Positively skewed, negatively skewed. What can you say about the
The
curve?
problem with Keshav is we have to explain the old system.
Positively skewed.
Positive. Okay, this is
Not the
actually.
new system that started from
Anybody
January.
else? Anybody else has any idea about this curve? What do you think this curve is? Dhanusha thinks it's positively skewed.
Not sure.
Right. This is actually a normal distribution. A normal distribution. This particular set of ages, because positively skewed now, we have a tail dragging off to a side, to the positive numbers, towards the positive numbers. But if you extend this hypothetically, if you extend this negative side, it's actually going to match to this one. This one, we can see that it is actually matching. It's not suddenly dropping here for this to extend this way. So this is actually a normal distribution. And that is why, because the ages are normally distributed only, that it was able to calculate the Z scores, right? If the set of scores that you have is not normally distributed, we cannot find Z scores. If there is a skewed distribution, either positive or negative, the Z scores won't have any meaning because it's a standardized score. We assume that all the range of scores that we have is in a normal distribution. You have the mean almost in the middle and very similar lower scores and very similar, that mirror each other. The scores kind of mirror each other. That's when you can calculate the Z scores. Right? Very important to remember. So if you have a curve which you can obviously see it's a positively skewed or negatively skewed, and somebody is asking for you to calculate Z scores, you say no, this is not normally distributed. No point calculating Z scores. Right? So basically, that's what that is, and then other than for that, the SSPS. We also have a place, of course, with SSPS, we don't need to do any of this by hand, but there is a table for figuring out whether a certain portion. So let me quickly share the screen again to show you that. This is your textbook. Okay. So when it comes to, you see, part of Z distribution listed in significance table, number of standard deviations. So this is your mean. You can see this is a normally distributed, this is a normal distribution curve, symmetrical, right? So you have your mean here and your Z score is here. So when you have your Z score here, you can say by looking at these tables that's up here, the part of the Z score, the percentage that is higher than the Z score can be looked at, calculated by hand by looking at these very complicated tables, in the sense not too complicated, but somebody has already done the job for us. So we know that if we have a minus Z score of something, let's say minus 0.2, right? In this column of the table, you have the percentage of scores higher than that particular score. So for a Z score of anything that you measure, right? The amazing thing is, if the Z score is minus 0.20, the percentage of scores that is higher than that particular score is actually already calculated. 57.93% is higher than that particular person's score, right? That is why the tables are given. So obviously when the Z score is the same as the mean, which is the Z score is 0 at the mean, that makes a lot of sense, right? Z score is 0 when the Z score is the same as the mean. Then the percentage of scores higher than the this particular one is 50%. So that you get 50% on either side. So that is, I hope that is clear and that is a bit obvious. So the higher you go above the mean, you see this. If you are 1.65, let's say for an A-level exam, a student gets 1.60, right? Z score is 1.60. The percentage higher than that is only 5.48. So if you have in Sri Lankan universities, if you're taking, let's say, 8% of all the children who pass their exams, right? 8% of all the children who pass their exams, they have places in our universities, let's say, then if only 5% is higher than this person who got 1.60, definitely this guy is going to university. Is that correct assumption? There's only 5.48% higher than him. So he's definitely within the top 8%, no? So you know that if somebody's Z score is 1.6, they already have a place in a university, right? So if only 8% are taken, what has the Z score has to be over? It has to be more than 1.4, isn't it? At 1.4, you have the top 8.08%. So it has to be more than 1.4. Your Z score has to be more than 1.4 to be able to get a place in the university. I mean, that's not the fact in Sri Lanka. I'm just taking that as an example. If it's only 8%. If they are taking the top 25%, let's say, then what? If they are taking the top 25%, your Z score has to be more than 0.7, right? The top 25% will be somewhere here, right? So your Z score, you know, if you've got about 0.7, 0.8, 0.9, definitely you can have a place in the university. Can you see now how this is working? You see the scores in this column, you see the scores higher than the particular. So these are tables that usually in statistics textbooks, you get these tables already. So if you don't have SPSS to calculate for you, you can easily see what percentage is higher than this, right? So now in the same manner, if you take one, Z score is 1, right? So what does this mean? 1 standard deviation above the mean. What's above it is 15.87, 15.87, right? So 15.87, take away 100, 50% of from the mean, you have 50%. 15.87, if you take away, it's about 34 point something, right? Just do that calculation. 50 minus 15.87 is 34 something. That is why we know that within 1 standard deviation on either side of the mean, you get 34 point something percent and 34 point something percent. There is a 68% of all scores fall within 1 standard deviation. That you can see very clearly from this table here. You have, when it's 1 standard deviation, you have more than 1 standard deviation, only 15.87% of the scores are falling beyond that, right? So below that is your 34 point whatever percent. Now, when it comes to 2 standard deviations, it's here. guess what? If your IQ score is 2 standard deviations, your IQ score is, if it's turned into an Z score of plus 2.2, you're in the top 2.28%. If your Z score is 2.2, that means 2.2 standard deviations above the mean, you're in the top 1.39%. Correct? There's only 1.39% of the world's population who has IQ scores higher than you. Do you see this? Understand the concept somewhat? Yes or no? Yeah, something? Okay. I hope, you know, just the Z scores and standard deviations are like mostly standard deviations. Z score is an application like of what you can get with the standard deviations, but standard deviations is used in any scientific paper, you know, because we need to know the standard measurement. Where do people fall, you know, within average, within one standard deviation, more than 2 standard deviations, which is an extreme, right? Usually an extreme. So that's okay. That's basically what we have for today. I hope you've learned something new, and your quiz, I hope you do it by yourself. And if you do it by yourself, once again, you might get it, you know, how this is all happening. So please try to do those calculations and see how you can get those same answers. That will be great if you can do that. Right? Okay, so